Good morning, everyone. So this video is about the realization of digital filters. So we have to realizable the filters in that four forms: direct one, direct form one, direct form two, cascade, and parallel. So at first do the direct form one realization. So first topic is direct form one realization. Okay. So in this problem we have to there's a draw we have to realize, that means we have to solve the equation and lastly draw the blocks with input and output. That is similarly equation, very simple equation, that is for the input and output. The xn in the input and yn is the output. There may be some intermediate state that we may be termed as a wn, like this. So here yn, that would be given in the form, that is summation minus summation ak yn minus k plus summation, so the summation limit for 1 to n. This for a part, this for the b part, that is summation of bk x n minus k, where the k turns from 0 to m. So you can see this from 1 to n, this is 0 to m. Okay. So after solving, that is a1 minus a1 y n minus 1 minus a2 y n minus 2 till a n minus 1 y n minus capital N plus 1 minus a n y n minus capital N plus, for the this for the a part starting from 1 to n, plus the b part starting from 0 to m, not from 1. So it becomes b0 x n plus b1 x n minus 1 till bm x n minus capital M. So this was the format of the equation, and we have to draw the figure. So xn is the input, so we are drawing at first the a part, that means at first we are drawing the b part with there is a coefficient of x. So this part is for x and b, and this part is for the a and y. Okay, so this is x. So first term is x with b0, so it is our b0, the sign is positive. Okay, so b0 having xn, so it is x1 into b0, this is the output. Next part is b1 x into n minus 1. In this n minus 1 termed as the, there is a one z transform. This is the input, this is the z inverse. Z inverse implies that n minus 1. So xn into z inverse means x into n minus 1. So this thing will be multiplied with the b1. This is b1 with a summation. That means it is our xn. This part is xn into b0. This part is xn minus 1 into b1. So this part is over. Similarly, for the other coefficients, it is z inverse it should be bm, and that thing must added with a summation, and in between there is some another bm m minus 1 b2, like this. Okay. So it may be like this, you can draw that z inverse, and this value becomes bm minus 1, there should be a summation, and there is a, like this is a structure for the xn that multiply with the b, and this part is for the yn that should multiply with the a value. So this is our yn. This intermediate state we can term as wn. That means wn is the summation of x and b. That means this entire part is wm. That means yn is equal to minus a1y plus minus plus minus plus wn or omega n, like this. So we're drawing the first part, yn. There is a yn and there is multiplication of nothing because yn is not there. It starts with n minus k, that is n minus 1, because k start is from the 1, not from the 0. That means yn having no terms, it is 1. Only the value is yn is not there. Okay. So next part should be, you can see it is a1 minus sign. So this term means yn into z to the power minus 1, that means yn minus 1 into minus a1 into yn minus 1. This is the entire thing. Similarly, this is minus a2 and again there is a z inverse. So this line becomes yn minus 2 into minus a2. So this line is yn minus 1, this line is yn minus 2. Similarly, this point is yn minus m plus 1 and this is ym. The value is minus a n minus 1 and this value is minus an. So this is the structure for the realization of, for the direct form 1. Next topic is the direct 2. So we will discuss direct 1 and direct 2 and then we will cover a problem based on direct 1, direct 2, cascade and parallel. This is direct form 2. So here yn, we know the value of yn, sorry, ak yn minus k plus summation bk x n minus k, where this k from 0 to m, but this k is from 1 to n. So in the last problem we can discuss that this is the last here, we can discuss that this entire thing we can replace by wn or omega n. That means this yn equals to the coefficient of a and y plus this x and b part, we can change it with the wn or omega n. So here this is the yn value, so you have to find the hz, the transfer function, you can say hz, that becomes yz by xz, that means output by input in z domain. So the thing is, we have to represent, so we discussed about what is z transform in the earlier class. And this is from k1 to n, this is k0 to m, this part is here. Okay. So this yz by xz may be like this way, yz by wz intermediate state, that is w, into wz into xz. So there are two functions. This part may be termed as this part and this part is 1 by this part, that is this entire thing may be termed as and this thing is okay. So let's take a problem. The problem is obtain direct 1, direct to cascade parallel form realization for the system where yn is equal to minus zero point 0.1 yn minus 1 plus 0.2 yn minus 2 plus 3x n plus 3.6 x n minus 1 plus 0.6 x n minus 2. So this problem we have to find using direct 1, direct 2, cascade and parallel. So we don't have any idea about cascade and parallel, but we will learn this in the subsequent in this problem also. Okay. So I already discussed about the every x for the direct one. The x part is the summation of x may be termed as the omega n or the wn. So for direct one, let 3x n, that means the this part, there is the x having part, plus 3.6 x n minus 1 plus 0.6 x n minus 2, it is wn. That means yn becomes minus 0.1 y n minus 1 plus 0.2 y n minus 2 plus omega n. So now we have to draw the diagram. So this part is for the xn, this part is for the yn. Input, output, intermediate is the omega or the w. That means input is x, total x, and there is a coefficient of x, and output is the w. This part is over, first part is over. For the next part is w is input, output is the yn. So let's draw it. So it is xn, the input, this is wn. Input, output for the first equation. You can see the first thing is xn into 3, where no xn minus 1 is there. That means there is no need of the z inverse. That means xn into 3, this part 3xn plus, that means now we need a x inverse because z inverse because it is n minus 1. So it is our z inverse. That means this point value is z, the value is x n minus 1. So x n minus 1 into 3.6. So this value is 3.6. There should be a summation. So this thing becomes wn equals to 3xn plus 3.6 x n minus 1. And last part is, again we have to do another z inverse. So the thing is, we have to keep that in mind, that if the value should be x n minus 3, then we have to put there x minus 2, because this z inverse, that means x n minus 2. So if the question is like this way, 3xn plus 3.6 x to x n minus 1 plus 0.6 x n minus 3, that means we have to skip one part. That means x minus 2 will be skipped. That means this is x minus 2, and if we need a x minus 3 or x minus 4, we have to put another z inverse block. So similarly, we have to put the value. The value is 0.6. We know this any summation because we don't have another part in the next part. Okay, so this wn becomes this part. So first equation is over. For the next equation, wn plus the coefficients. So we have the value of the wn. Here wn is there. This is the structure. It is the yn. That means till this the equation is yn equals to wn. Now you have to put yn minus 1 and for yn minus 2. That means z inverse, z inverse. So this is the first z inverse for yn minus 1 and the coefficient is 0.1, sorry, minus 0.1. Minus 0.1. Next part is for yn minus 2. That means again we need another z inverse. Now the value becomes yn minus 2. Coefficient is plus 0.2. This is 0.2. So that's all for the direct one. Next part is the direct 2. For direct 2 you have to find the hz that is in the form of the yz by xz. So hz becomes, transfer function becomes output yz by xz, the input. So after the z transform we apply in the question, that means it becomes yz. So I can write here also, that is yz equals to minus 0.1 y z to the power minus 1 plus 0.2 y z to the power minus 2 3x z, sorry, it should be yz into z inverse. It is yz into z inverse plus 3.6 xz into z inverse plus 0.6 xz into z to the power minus 2. So we have to keep that mind is here. So we can write that hz is equal to the coefficient of y by the coefficient of the x. As you can see, there is a y in by x. So the coefficient of x, coefficient of the y. So the coefficient of x is 3 plus 3.6 z to the power minus 1 plus 0.6 into z to the power minus 2. For y part, that is 1 plus 0.1 z to the power minus 1 minus 0.2 z to the power minus 2. So here we have to keep in mind the sign, because there is a change of the sign. This is minus 0.1, this is plus 0.2, this is plus 3 plus 3.6 plus 0.6. Just keep it here also. Just keep that in mind. The sign should be changed. So it is the input, the x. This part is same, but the thing is there are 1, 2, 3, 4 z inverse block that are there. But in direct 2, we are reduce the z inverse by 2. That means here we have to use for y 2 z inverse, for z, sorry, for x there are 2 z inverse. So we can change it in this way. There is only 2 z inverse, 2 for the x and 2 for the y also. Just see the value. So you can see this is the xn, this is the yn. Thing is similarly with this. This part is here, this part is here. Very simple. These Z inverse are here, these Z inverse are here. So in this part, this minus 1, sorry, 1 point, minus point 1, point 2 here. So you can also term this 1 also, because there is nothing here. So this part is here and that part is there. Very simple. This is the direct 2. The question is the cascade form. In cascade form, we know the value of the y z by x z. Now we have to split the hz into two part, mainly two part. That should be h1z and another part is the h2z. So we know that hz from the last equation, hz is equal to yz by xz. The value is 3 plus 3.6 z inverse plus 0.6 z to the power minus 2 by 1 plus 0.1 z inverse minus 0.2 z inverse. We have to split hz into minimum two part, that you can use the Discrete-time factor also in the last equation. So this output becomes 3 plus 0.6 z inverse by 1 plus 0.5 z inverse into 1 plus z inverse by 1 minus 0.4 z inverse. So this part is h1z, this part is h2z. So again the form is basically similar to direct 2. For direct 2, hn is the input, one summation is there, another summation, we need only one z inverse because the power is only z to the power minus 1. So you can see the xn is the for this problem. This is 1 and minus 0.5 to the denominator, sorry, the denominator, and this part for the numerator 3 and 0.6. So this part is the h1 part and next is the h2 part, and output is the yn. The problem is similarly to the direct 2, only one z inverse is needed because there is only one z inverse is there. So this value is 0.4, this value is 1, this is 1, this is 1. The thing is that you have to keep that in mind, that is, it is, the formula is like this way, the all plus, there is the, in the numerator all the plus value, in the denominator the value should be 1 minus some values. You can see this value is 1 plus 0.5, the sign of the 0.5 is plus, but the thing is it should be 1 minus of minus value, that is 1 minus 0.1 minus minus 0.5, that means 1 plus 0.5. So this value, the sign becomes minus 5 because it is, I'm again repeating that this is the all plus value and the denominator the value is 1 minus minus sign, it is 1 plus 0.5, it should be 1 minus the value, this entire thing will come here. Similarly for this is 1 minus this sign, this is plus sign, this is plus, the value itself is minus because minus into minus should be plus, and here it becomes 1 minus the value, and this value should be positive because it is plus into minus becomes minus, so plus value is here. So you can see the similarly in the cascade 2 also, that is in the direct 2 also, this part. So this is for the cascade. Next, the last part is the parallel. In case of parallel, so we have to divide the numerator with the denominator. The entire problem will never come in the exam. For the exam purpose, we have to solve the problem for the four part. This is the combination of the four examples. Okay. So we know the simple divider should I know. So if you take minus 3, it becomes minus 3 minus sorry minus 3 z in, sorry should be point 0.3 z inverse plus 0.6 z to the power minus 2. We have to minus the value. So now the value becomes 6 plus 3.9 z inverse. That means 8z becomes minus 3 this part plus 3.9 z inverse plus 6 by this value 1 plus zero point 0.1 z inverse minus zero point 0.2 z to the power minus 2. So we know how to solve the problem using the partial fraction. That is, it should be minus 3 plus a by 1 minus 0.4 z to the power minus 1 plus b by 1 plus zero point 0.5 z to the power minus 1. We know how to split the value. So for this value we have to already split the value here. Okay. So after partial fraction, the value becomes minus 3 plus 7 by 1 minus zero point 0.4 z to the power minus 1, and the b value is minus 1, so it is 1 plus zero point 0.5 z to the power minus 1. So you have to draw the figure for this answer. Okay, where xn is the input. Some complicated circuit is there, but we need to practice this. This value is minus 3, this value becomes minus 3 here, and after the summation this value is only 1 z inverse is there, so this value is 7 and this value is 0 0.4 for this part, 0 0.4. So again it is minus sign, but it is plus sign because for the realization 2. So 3 for this part, this is for this part, and we have to write for this part also. Summation minus 1, only 1 z inverse, so this value becomes, it is plus 0.5, so it should be minus 0.5, and this is the output yn. Apart from these four types of realization, there should be another two types, that is the lattice ladder or the transposed right from the realization. But the main four things we have already discussed. This four is very important for the exam purpose. So that's all for the chapter. The chapter is basically in this class we have discussed about the realization of digital filters. It can be two types of filters realization. One is a recursive and another one is a non-recursive. For recursive realization, the current output yn is a function of a past output and the present and past inputs. This form corresponds to a IAR filter design. So we have already discussed this. Another part is the FIR, that is for the non-recursive realization, where the output sample yn is a function of only the past and present input. That is for the FIR filter. So that's all from the IAR. In the next class we will discuss about the FIR filter. So how to design the using some rectangular window, Hemming window, Henning window, Kaiser filter. That is we will discuss in the subsequently in the next class. So till now we have to study this topic, and there is no the four problems. It is a combination of the four type of problem. So in the exam we can expect at least two type of problem in for the semester also. For the direct 1, direct 2 are very important, and we cannot skip the cascade and parallel also. But we may skip the lattice and the transposed if they are not very important. But for the exam purpose, we have to study this, because in the exam we cannot say what the question will be there. Okay, till then, thank you.